x is my x, my 1/3 minus is 1/3 minus, and my remaining negative 4/5 is negative 4/5. The integration was correct because I differentiate. Notice this logic, people. I'm saying that differentiation will always be slightly easier than integration. I'm saying that. That, I think, always remains true. That's why I confirm integration with differentiation, not the other way around. If it's the other way around, you won't feel comfortable. Because you naturally differentiate, more easily, let's just say, you feel comfortable confirming integration with differentiation. This is more like a natural process, a natural response. If somebody don't feel that way, you must tell me so that at least I understand your position. This is the position of most people, you see. Okay, now, again, I would like to see some thumbs up here. I do need to confirm that you feel differentiation is more manageable than integration. That's just your feeling, right? Okay. Okay.
Teacher,
Yes, Nicholas.
wait, may I ask the difference?
Oh,
Integration and
yes.
differentiation. It's like, which one? How do I tell? How do I know which one's which? Which is which?
The easiest way is to see the power. Don't look at things too much. Look at the power. If the power is decreasing by 1, that's differentiation. If the power is increasing, that's integration. That's
Oh,
the
okay.
thing. If that makes sense, the fraction in front follows later. Okay, I hope that makes some sense, yeah?
Then differentiation is easier.
That's just general response of everybody. I'm actually not telling you that. I'm saying check with yourself, correct or not? Something like that. That just feels better. I don't know how to describe it. Okay? All right. Now, this is the basic differentiation and integration. And then I introduce you 3 exceptions. The exceptions, thankfully, are easy to remember because they, again, don't make sense at all. I'll show you the easiest one. The sine, cosine, minus cosine. I'm so sorry. That's wrong. Sine, dot, 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 dot. Okay, going up integration, going down differentiation. That's it. The third one, even easier, it's just that it doesn't make a lot of sense. How come differentiation of EX is also EX? Integration of e power x, also e power x. Don't know why, but that is true. And that is an exception. It doesn't look like the basic thing, It doesn't look like it at all. Now, the last one is, I believe, the weirdest one. Logarithm natural x, x power minus 1. Going up is integration, going up is differentiation. This one is the hardest to get naturally. You have to memorize this. Okay, my apologies first. Okay, apologies first. Now, who can tell me the
Teacher,
integration? Yes, Nicholas.
may I ask what's the third rule? The EX equals EX. Isn't it like,
Not EX. No, no, no. EX differentiated, also EX.
oh,
They
differentiated?
remain exactly the same. It's very weird, but it will be correct as you progress. I am asking you to memorize all this. My apologies, but yeah, I don't explain. Now, I want somebody to answer what is the integration of logarithm natural x and what is the differentiation of x power minus 1. Brave soul, volunteer, please. You can look at your notes, okay? I don't mind. This is just a revision. But brave soul, answer something.
This one also repeats, right? Like,
Which one? Are you going to integrate or differentiate first?
like
Okay.
logarithm
You wanna integrate logarithm natural x, am I correct, Ariel?
Yeah.
Okay, and what is the integration of logarithm natural x?
It's just x to the power of minus 1, yeah.
Now, integrating is going up in that sense. What you're mentioning just now is going down. It does not repeat.
Oh, okay.
Which is to say, in your previous note, okay, be strong in your graphs. I'm telling you this is out of syllabus because it is actually very difficult to do.
Oh, okay.
This does not make sense. I'm just telling you facts for now.
Oh, okay.
I am revising and the fact does not make sense. Again, I apologize. Integration of logarithm natural x, you do not know, it is out of the syllabus, it is hard. Okay, right. Okay, yeah. Good, Ariel. I still like that you move on. I still really like that. Another person, please volunteer for the differentiation of x power minus 1.
Negative x to the power of negative 2.
Which is to say, this is basic. Am I correct?
Yeah.
Good. Now, by the way, this is non-basic at all. It's an exception, and we don't know. This is also non-basic. Just saying. Basic means this one, the three-step thing. Okay, so the hardest thing about logarithm natural x and x power minus 1 is that it continues to be basic. But when you go up, it does not. It kind of introduces to you a very jarring contrast. Do not underestimate this. You will have a lot of trouble, even though I have told you. But less trouble compared to other people. Now, any questions so far? This is almost the revision of last week. Okay, now, the second part of the revision, very fast. We call it the three rules. The three rules of differentiation. Maybe somebody can remember the name. Maybe Nicholas, you can remember the name. The three rules of differentiation. They have a formal name, whatever that is.
I don't remember. Oh, no. Three rules.
Yeah,
Product
but you must
rule,
look at your notes.
quotient rule, and chain
Yeah,
rule.
yeah, nice. Product rule, just say the times rule, easier. That's what it means actually. Product rule, times rule. Quotient rule, division rule. And one more chain rule, which you do not know what it is. Turns out everybody don't have problem with product rule and quotient rule. Turns out nobody have. Okay, easy to memorize. Brave soul, Eben. Sorry, if I point you there, it's not brave soul. Eben, answer, product rule or quotient rule? Which one is it? Just look at your notes. It's pure memorization anyway. Come on. Eben, are you okay? Eben.
Oh yeah, I didn't write this one down.
Okay. Do write it down because you'll be using it a lot today. Okay, so guys, u prime, that's a very bad u. U prime v, prime means differentiation, remember, plus uv prime. Okay, whatever that is, we apply that, we are correct. Anybody can mention to me the quotient rule? Matthew?
U prime V minus UV prime over V squared.
Good. As you mentioned it, you're correct, Matthew. Good job. Everybody else who remember, good job. It doesn't feel natural. It feels like something you apply. For now, that's it. Chain rule is the worst because there is no formula, so to speak, no formula, but it is the most popular one. And it is sometimes not very obvious, sometimes. This is what I have to show you today. We have to start with chain rule, okay? Because why? No form, very popular, okay? And I'm so sorry, it doesn't make a lot of sense also. I'm really sorry about this. Okay, it doesn't make a lot of sense also. But after that, we are done with the rules. Now, the last thing before we continue, we have three rules for differentiation, and this is all you need. This is all you need. We have no rules for integration. Is this good news or bad news? Let's check it out. Ariel, good news or bad news?
Good news.
Good news, until you realize it means integration is way harder. So depends whether it's good news or bad news. If you can do integration, which is harder, then good news for you, a lot of models, right? If not, we'll take it slowly. Now, let's go to chain rule first. Oops, sorry. Okay, that's it for the revision, right? Okay, a better way to see chain rule is onion rule. You have layers. I will now introduce a function with layer. Layer means inside and outside. Sometimes you have three layers. Okay, I'll introduce you 2 layers first. Something like this. Sine x. To differentiate sine x, it is cosine x. You know that. Okay. Now, I'll introduce you a layered function. Inside sine x, instead of putting x, I give you sine, well, 2x. Okay. Okay. For sine 2x, we need chain rule, whatever it is, because there is a layer inside and outside. This is how you identify that you need a chain rule. There's an inside and there's an outside. The inside is 2x, it's not the normal x. So the differentiation is the normal cosine 2x. This is the normal treatment. And then times the integration, I'm so sorry, the differentiation of 2x, this is our chain rule. Chain rule is just saying I have something extra to do if I have a layered function. I have to do something about the inside. So what is the differentiation of 2x? Very simple, yeah? Joel, what is the differentiation of 2x?
Is it negative 2x to the power of minus 1?
Uh-oh, right, let's try that again. You're saying that the differentiation of this negative 2x to the power of minus 1, correct?
Yeah,
Let's
okay.
try that again, Joel. Okay, this is power 1. Now let's try this. The
Oh, so
differentiation
it's
is
the 1.
x to a power 0, right?
Oh, minus 2, sorry.
1. Okay, so instead you have number 2.
Oh, okay, can.
Number
Sorry.
2. No problem. Remember, differentiation, even though easy, it doesn't make sense one. That's why you can
Sure.
make this kind of mistake. Yes, Nicholas?
Does it say chain rule?
Chain rule, chain rule. I did say chain rule. I'm sorry, my writing so bad. Now, the differentiation of 2x is 2. And therefore, the differentiation of sine 2x is 2 cosine 2x instead of just, it's not just cosine 2x. This is the chain rule in application. Whew. Nothing much makes sense. Maybe there's a question so far. Okay, I will now train your instinct in, oh, this is chain rule. Oh, this is chain rule. Oh, this is not chain rule. Oh, this is product rule. Oh, this is quotient rule. Okay, I will now train your instinct on that. Okay, prepare to, maybe everybody just unmute for now. Okay, now, sorry. If you think this is basic, you're saying that, oh, I don't need a rule, teacher. I don't need a rule. Okay, cosine x, do we need a rule or not, Anu?
No.
Because the differentiation is you memorize what?
Uh,
Come on, sine, cosine, minus cosine, which is?
minus sine x.
Yeah, yeah. Just out of memory though. Yeah, so we're just getting used to it. Okay. Cosine 2x. If you feel this is basic, say it's basic. If you feel I need a rule, say which rule. Eben, basic or we need rule?
Uh, chain rule.
Chain rule. Thank you. Who is the inside? The moment you say the correct inside, you are correct. Who is the inside?
2x.
2x. So therefore, people, what is the first thing that we do? The first thing we do is we do things normally. Minus sine 2x. This is like a normal thing, right? Because cosine x becomes minus sine x. So cosine 2x becomes minus sine 2x lah. This is normal. The second thing is your chain rule. This is your chain rule. What is it? The differentiation of 2x. What is it, Eben?
It's
The
2.
differentiation of 2x is 2. Thank you very
Yeah,
much.
2.
And therefore, this is the answer. I have just applied chain rule, and then you are correct. Let's continue. The instinct of chain rule or product rule or whatever. Cosine x times sine x. Ariel, basic or rule?
Times.
Times rule. They call it product rule. What is it? U prime V versus UV prime.
Oh,
Okay. You kind of just revise for us. This I am so sorry. Okay. This is your U. This is your V. So what is U prime, Ariel? Differentiation of cosine x. Come on.
Minus sine x.
Thank you. Doesn't make sense, but you're correct. Thank you very much. V prime. Differentiation of sine x.
Cosine x.
Thank you very much. Doesn't make sense, but you're absolutely correct. Apply U prime V plus UV prime. Assemble for us, please. Come on.
What
U prime is.
U minus sine x.
Thank you. V.
Cosine x.
V is. V.
V.
Not V prime.
Sine x.
Yeah, pay attention. Doesn't make sense. Doesn't mean you can lose focus. U is.
Cosine x.
Thank you. And V prime.
Cosine x.
Simplifying, minus sine x times sine x is. They write down as minus sine square x, something like that. Which you cannot. Can you guys see my writing? Wait, can you guys see my writing? Okay, never mind. I put it down. Okay. And then cosine x times cosine x, Ariel.
Cosine x. Cosine square
Sine
x.
square x. Okay. If you were to reorganize, cosine square x minus sine square x, something like that. Some people will recognize this as the trigo identities. I will not go further than that. For now, this is it. Okay, I have just revised with you a product rule. Doesn't make sense, but it's almost formulaic. Any questions?
Teacher,
Yes.
I kind of, wait, I wasn't listening just now when can you tell me what sine x arrow to cos x means and cos x arrow to minus sine x means?
This thing, isn't it? This thing? This thing?
No. You see that big sine x arrow to cos x, on top, and the cos x arrow to minus sine x.
You're talking about the previous question.
I didn't know. I don't understand from the start.
Okay. One more time, eh? One more time. Nicholas, answer me. Cosine 2x, basic or we need rule?
I don't know.
The answer is we need rule because there is an inside layer and an outside layer. Now, one more time. Cosine 2x, rule or basic?
Rule.
Because okay, one more time, Nicholas, yeah. I know it doesn't make sense, but I'm describing certain things that you can observe. I'm not saying that this makes sense. This one, I apologize. A lot of things doesn't make sense right now. Again, this one, I really apologize for everybody. Those who can do this also do not understand it one. They're just following what I'm saying. Nicholas, I am asking you to kind of follow the way I do things for now, yeah? Cosine x is basic. Correct, Nicholas? Nicholas, you not afford to wait too long. Basic or not?
I don't know.
Because I asked you to memorize here. Cosine x here. This is basic. It's just the differentiation is simple. The integration is simple. Okay, Nicholas?
Okay. But what is
Cosine
simple,
2x.
basic, and whatever? I don't know.
Yeah, but basic is this. Basic is this. Basic and exceptions. Okay, basic and exceptions. Okay? You cannot wait too long, eh? Cosine 2x
Okay.
is not basic because of the 2x. Just because of the 2x. As a result, I must do a modification. But do the normal thing first. This is called a normal thing. Why? Cosine x differentiated minus sine x. Doesn't make sense, but cosine 2x differentiated minus sine 2x lah. Normal thing to do. The chain rule has an extra. It's an extra step for the chain rule because you recognize 2x is a possible problem. Differentiate the 2x, make it 2 like that. In front. This does not make sense. I am so sorry, but this is chain rule. If you don't understand Nicholas, my advice is very simple. Practice until you get the feel. I don't know how else to explain this. This does not make sense. It just will be correct.
I don't understand anything.
Yeah,
What is
Nicholas, I
basic?
understand.
What is exception?
Okay, Nicholas, follow me in the practice. I'm not offering explanation to anybody else also. Not right now. I am not offering explanation right now. Okay, hear me out. I am not offering explanation, and I do not do this often. So you got to trust me on this. That means it really means it's very difficult to explain already. Okay, this is the same for everybody else. Now, I'm trying to train your instinct. There is no other way lah. There's no other way. Joel, basic or rule?
Rule.
Okay, and what rule?
Is it the chain rule?
Because there's an inside, correct? So
Yeah.
what do we do with the chain rule? Do it normally first. What would that be?
3x will become
Do
Is
the
it just-
cosine 3x. It's just easier.
Oh,
Do the
sorry.
cosine 3x
Cosine
first,
3x,
but
yeah.
then put something in front, which is
3.
3, which is the differentiation of cosine, with differentiation of 3x.
Yeah.
Nicholas, I get it. We don't understand, but follow. Write this down. Don't look at it. Write it down. Same with you, everybody. People, don't stare at this. No amount of understanding will happen when you stare at it. It's a habit thing. Okay, and you're good at habit. Right? You're good at it. Now, I'm switching things up. Tangent x. Okay, I need some brave soul here. Matthew, you're the brave soul. Tangent x, basic or not basic at all?
Not basic.
I agree because you don't see tangent x anywhere here in the summary, correct? There is
Yeah.
no tangent x here at all. So agree. So you're thinking, people, Matthew, everybody else, oh, tangent x must have some rule. Matthew, can you figure out what rule may help? If not, I will help you. Is it the times rule? Is it the division rule? Is it the chain rule? Is anything helpful here?
Chain rule.
Chain rule. Nice. No times, right? No division, right? But the problem is no inside also. Correct or not, Matthew?
Yeah.
If you want to apply chain rule, what's the inside? Nobody knows. So I'll give you a hint. Now I am applying trigo. For those who don't like trigo, this will be a very unsavory combination, a combination between trigo and calculus, but they will do that a lot. I am just helping you do it better right now at this point. This is very unsavory for people who do not like trigo. But can Matthew tell me, Matthew, why do I suggest making tangent x into sine x over cosine x? Besides the fact that it is correct lah.
So it becomes easier to do cosine sine x over cosine x. You can just use quotient rule.
Very good. And tell me, for memorization purpose, what is the cosine rule? Yeah, you did that just now. Hey, come on. Come on. Okay, u prime v minus u v prime over v square, right? Just memorizing. This is the u, this is the v. Matthew, you're going to do it with everybody else. Well, preparation, please. What is u prime?
U prime will be sine x.
Hey, u is
I mean
u prime is.
cosine x.
Thank you very much. Getting used to it, all the muscles. Nicholas and everybody follow, yeah. Follow. What is the differentiation of cosine x? Matthew?
Negative sine x.
Thank you. Doesn't make sense, but you're getting it. Now apply the product rule, Matthew. What is it? Assemble.
Cosine x
Thank you. Then
times
times.
cosine x
Thank you. And then
minus sine x times negative sine x.
yeah, okay. Because that's the v prime. And then over v square, which is
Cosine x square.
which is written as cosine square x.
Yeah.
Now, everybody, I am asking you to write this down. So that's your way of accepting what I'm saying. Your teacher will do the same one. There is almost no easy explanation. We can only say this is correct. I guarantee you this is correct. Ariel, Nicholas, and everybody else, write it down. Currently, there's no other way. Some of you will hate this. Some of you will like this. Go to it. Okay, go to it. Now, let's simplify. Eben, simplify for us. Come on. Cosine x times cosine x is
Cosine square x
cosine square x minus
minus negative
Right.
sine square x.
which is a positive, right? Which is a positive, correct? Over cosine square x, correct? Eben, do you remember the trigo identities? Cosine square plus sine square is? If you don't remember, it's okay. Do you remember? Okay,
I don't remember.
no problem. It's not a memory test here. I'm just asking did anybody remember trigo?
Sure, is it 1?
Yes, 1. This is a very unsavory combo. Again, I apologize. This will happen sooner or later. Might as well just get you used to it. 1 over cosine square because identity of trigo. Okay. 1 over cosine square x, another trigo. Okay, a deadly combination of calculus and trigo. This is called secant square x. This is what your teacher will expect. Calculus and trigo. You don't like this? Do it with me, man. Do it with me. Now, any questions?
Teacher,
Yes, Nicholas.
that's cos square x plus sine square x,
Yeah,
right?
yeah. And the identity makes it 1 from trigo, long time ago, 2 months ago. Now, look at what we end up, people. We start with, I'm so sorry. We start with tangent x. We apply quotient rule, and we end up with something quite simple. This is rather common. This happens, and that's what they expect. To be fair, they give you at least 3 marks for this. So that's something, that's this. If you have no more question, I will keep repeating this because I'm trying to drill something. I rarely try to drill something. This one definitely must be done. See, I'm wrong again. Now, logarithm natural x, basic or not? Joel.
Yes, is the exception, right?
It is an exception, but still basic. Differentiated is?
Let me check my notes. Sorry.
Oh, go ahead. Please check your notes. Go ahead.
X to the power of -1.
Correct. Now, good job, Joel, for demonstrating to us the instinct is somewhat to check the note. I am asking you not to memorize too much. I'm just asking you, oh, I know roughly what's going on. Let me see my notes. Do not panic. Do not think. Instinctively check something that helps. That's the nature of calculus. Apologies for that. Check your notes again, Joel. Can we integrate?
No, it's out of syllabus.
Can we differentiate x power -1?
Yes.
which is,
To negative x to the power of -2.
and so on and so forth. Okay, hopefully, people, you understand this from your notes. Okay, we're drilling here. Now, still Joel, logarithm natural 2x, basic or rule?
Is it chain rule?
It is chain rule because on a chain rule, you have to identify the in,
The inside,
and the
just 2.
inside is 2x. So now I teach you do a natural thing first, just differentiate normally. What is it? Look at the comparison at the right, okay? Look at this, and therefore look at that,
Is it 2x to the power of -1?
which is parroting, copying, doing what is happening here. I hope you guys can see that. You are copying or doing what is already present in your notes. Doesn't make sense. I get it. But as a chain rule dictates, you have to have something extra. What is it, Joel?
Which is the 2, which
2.
is the
The 2
differentiation
lah.
of 2x.
Yeah, which is 2. Right? And we leave it at that. This is the differentiation of logarithm natural to x. It's confusing, but that's why I'm training you. Okay. Nicholas, let's try, yeah? Let's try. Let's try together. Okay. Logarithm natural sine x. Basic or rule?
Mm, mm, Basic.
No, there's nothing basic with logarithm natural inside sine x, correct? Because you cannot see it in the notes. This feels more complicated. Would that make some sense?
Okay.
Okay, you have 3 rules: times rule, divide rule, or the inside rule. Which one is it?
Ins
Because the inside is, I'm so sorry, because the inside is,
Sine x.
all right. Now, when you realize this is the inside rule or chain rule, first thing first, you differentiate normally as if it is a basic. This is the hard part, Nicholas and everybody else. What is the first step here? Okay, I want you to look at what happened here. This is logarithm natural x. Differentiated becomes x to the power of -1. That's basic, even though it doesn't make sense. In this situation, what should be our first step? Nicholas, can you try at least? It's going to feel very weird, but please try.
Um, I don't know.
All right. Then I'm going to help you. It's going to be sine x power -1 because I'm just following what's happening here. Okay. Then chain rule dictates there must be something extra. What is the extra? The differentiation of the inside. Kirana, what is the differentiation of the inside?
Cosine x.
And therefore, put the cosine x here. Thank you very much. Okay. This does become cosine x divided by sine x, which does become cotangent x. But that's more trigo, so I will just ask you to at least consider it here. Okay, just here. Okay, just stop until here at the very least. Okay, who is a bit overwhelmed right now? Okay, thumbs up, please. Okay, Nicholas, and I appreciate that you will follow me for another 5 minutes. I understand that this is very overwhelming for you. You're not the type. You're not that type. I understand. But please follow me, yeah? Okay, more difficult things to come. E power x, basic or not, Ariel? Look at the notes.
It's an exception, but
Yeah.
it's basic.
But kind of basic, so the differentiation is?
It's still e to the power of x.
Thank you, and therefore the integration?
It's still e to the power of x.
as nonsensical as it seems, no matter what it is. Okay, so now e power sin x. Ariel, basic or exception? Basic or rule, sorry.
I think it's a rule.
And which
Oh.
rule? Times, divide, inside.
Sorry, what?
The times rule, the divide rule, or the inside rule?
Oh, I don't know.
Mm-hmm. Let me try to think about it this way. There is no times here, correct or not, Ariel? There is no times here. That makes some sense, right? There is no division here also. There is no time and there's no divide. And yet, this does not look like basic at all. You can just immediately jump to, hey, this must be inside. Okay, let's just call this inside. This is inside. Okay, this will be the heaviest thing, and then we'll take a break. So this is the inside. So we need to use chain rule. When we use chain rule, we do the most normal thing first. Normal. The normal thing is just pretending that the differentiation is like that. Why am I saying that? Because the differentiation of e power x is e power x. So normal-wise, the differentiation of e power sine x is e power sine x. This is normal. Okay? And then the extra comes. The extra is because, oh, this is chain rule, extra. What is the extra? The differentiation of the inside. Matthew, what is the differentiation of the inside?
Cosine x.
And you put cosine x here. And then times that. And then you are correct. We are repeating the same thing through many different variations. Now, even though we start a bit late, we're gonna probably take a break for now. This is a little bit too much already, for some. Yeah. Okay, take a break, but let's take a break for maybe 7 minutes. Those who want to discuss with me can discuss now lah before taking a break. Okay. Right. Okay, suppose I'll ask Nicholas. Nicholas, before taking a break, do you want to discuss again? I'll try my best to make it easier. Okay, do you want that, Nicholas? Or you just want to take a break? That's also fine, no problem.
I'll take a break.
Okay, taking a break is also a good idea.
Wait, can I ask questions?
Yes, Ariel, go ahead.
Oh yeah. So because you said that like
Oh, sorry,
the
sorry,
e
sorry,
to the
sorry,
power
sorry,
of
sorry,
sine
sorry,
x.
what happened? Sorry, just a minute. Just a minute, what happened? Yeah, sorry, you're saying? Oh, my share screen is gone. I'm so sorry. Let me, let me do that again. I accidentally closed my iPad, you see. Wait. Yes, Ariel, your question is?
Because you said like e to the power of sine x is like inside.
The sine x is the inside, and
Okay.
the inside layer, the e power is the outside layer.
So it's both for that and like just
Both
sine
what?
something.
Sorry, both what? Sorry.
Because this thing the funny chain rule thingy also
Okay.
works for like when it's sine 2x and there's no power. So it's like it works for both.
Okay. I believe you're referring to this guy, maybe, like that.
Which one?
Sorry, are you referring to this guy, perhaps? Is it this guy?
I
And you're saying that this is a times, am I correct? Ln times 2x.
It is Yeah, it's not just like so my question is it works for both like power and like times kind of.
Okay. Now, Ariel, this is a long-standing misunderstanding between Matt and you. First of all, I think Matt has some apology to make. He makes it as if this is times. This is not a times. I truly apologize. This is not a times at all. Logarithm natural bracket x does not mean logarithm natural times x.
Wait,
It
no,
really
I know
does
that. I
not
know that.
mean.
I didn't mean that.
Okay, then which one do you mean?
Wait, no, because no, I meant like the thing for e to the power of sine x.
Okay, yeah, which is not a times lah, correct?
Yeah, it's not times.
Uh-huh. So it works lah. Chain rule, of course, chain rule works for things which are not times. If it is times, product rule is the best, correct?
Oh, okay, that makes sense.
Okay. But chain rule will not be applying itself to a time situation most of the time. No. That's product rules job. That's quite
Okay.
a nice division of job, I guess, something like that.
Okay.
Okay. Don't think about chain rule when it's times, Don't think
Okay.
about times when it is a layer, Don't do
Okay,
that.
so when it's chain rule, it's just that like the whatever's inside stays the same. And
The first step lah. The first step is to
yeah.
just pretend the inside is, a very
And
just
then you
pretend that the inside is there lah.
differentiate
Just
the
leave it
outside.
there, but then do something extra to it, something like that.
Okay, so then it's just the inside like differentiated, then you put it at the front.
Correct. You're
Okay.
just pretending, and that's the way to do chain rule, even though it does not make sense at all.
Okay.
I think you get it.
Thank you.
Okay, good. Have a break. All right, let's do a mic check. Anu, are you here?
Yeah, I am.
Okay, good. Anu, Ariel.
Yes.
All right, cool. Evan.
Yeah.
Okay, cool. Joel.
Yeah.
Okay, cool. Matthew.
Yeah.
Okay, got it. Nicholas.
Yeah.
Okay. Kirana.
Yeah.
Good. For those who don't mind following things, this will not appear to be very heavy. For those who have trouble, like Nicholas, there's only one thing I can offer to encourage you. If you do this, after a while, things does become easy and you will get marks for it. For whatever this is worth, it is worth a lot of marks, lah. Something like that. So let's do the hard things during holiday lah, when you have energy, right? For whatever it is worth, I think we're doing it at the right time. I don't think we want to do this when every subject is getting hard, which is what's going to happen in Sec 4. Let's do it now. Okay. Then, Nicholas, appreciate you keep trying. Now, today is probably the heaviest day, right? If somebody cannot take it for the next half, please tell me. I have to go through one more hum lah. Okay. One more hum for today. Okay. Now, I have to show you integration a little bit, right? Okay. Some of you will find this heavy. Some of you will be able to do it. Anything, as long as you follow me for now. Remember, this is a chain rule. So cosine to x times 2 lah, right? Normal, like that one. That's your differentiation. Now, I will show you an integration because by right, you learn them side by side. Okay. Now, remember, an integration is harder. What that actually means in exam question is that you're forced to make a lot of guesses. You are forced to do a lot of guesses and then you make checks. For those who think they should take more math in year 5 and year 6, this is mainly what you do. That's for your consideration. For now, I'm just telling you, harder simply means more guesses because there are no rules. There are really no rules to help you. In some way, that's worse than differentiation, right? So now I will make my guesses. For example, I just guess lah. What else is there? Guessing is just guessing ma, right? So I guess the integration of sine to x must be minus cosine to x. That's a guess. Okay, I hope you can see where I'm coming because the normal integration of sine x is what, Kirana? You can look at your notes, remember? You should. Instinctively, you should. People, you should, okay? You should.
Yeah, can you repeat?
The integration of sine x.
Minus cosine.
Right. Thank you, Kirana. Whatever that is, it is correct. It does not make sense. So you can appreciate my guess. Oh, I'm just guessing it's minus cosine to x. Okay. How do we check? We check by differentiation, right? Matthew, to start off. Oh, sorry, Kirana is not. Matthew, do we need rule or it's just a basic thing?
You need the chain rule.
Which is because there's an inside, correct? There's inside there. So
Yeah.
what do you do with a chain rule? You do things as if normally, correct? So please differentiate minus cosine to x kind of normally first, and that will be?
Teacher,
Yes, Nicholas?
may I just ask one question?
Yes, please.
Why is it, how do you know the extra is like 2?
Oh, the extra is the differentiation of the inside. That's actually the chain rule. That's the way to deal with the inside. The differentiation of 2x is 2 lah. Why is that a chain rule? Don't know, no explanation, but that is the chain rule. Okay, that is the chain. Okay, still a good question because it doesn't make sense now. We have to repeat this all the time. Matthew, differentiate minus cosine 2x, please.
Sine
Right.
2x.
Sure. And that's the normal way, right? And then what do you do the inside?
Differentiate. So
Which
it's
is 2,
2.
right? 2. Now, we are checking. Remember, I was guessing, and then I'm asking you to check. And lo and behold, Matthew, everybody else, is that the same thing? Did we go back to the original thing? Did we go back to the original thing?
No.
No, them. Just everybody can see. Oh, no, my guess is wrong. Hey, integration like that one. I guarantee you, because there's no rule. There's no rule. Integration like that one. Oh, is it that bad? Joel, is it that bad?
Not really.
What is the difference here?
Is multiplied by 2 on
Okay.
the original.
So if this is the difference, A, it's not that bad. So oh, it's not that bad. Maybe Joel venture a guess. How can we modify our original guess?
Divided by 2.
Okay, I'll put it as times half. Would that be okay?
Yeah.
Okay. Now, if my original guess, I will now modify by times half. Why do I do that? Because I observe I have an extra 2 if I don't modify. Hey, does that mean I am so sorry. Does that mean my differentiation also only times half? Well, yes lah. And then as a result, I will now be correct. Some will be confused, some will be able to accept this. Because now I am correct, I have concluded that my integration is half, minus half cosine 2x. That would be the correct integration. Whew. Does this make some sense? If you want to ask questions, better ask now. Okay, let's try again. Okay, this is a hum, follow me, please. Follow me. This is a hum. Okay, cosine 3x. Let's differentiate cosine 3x. Eben? Remember, chain rule.
Negative sign. 3 negative sign x.
Good. That's because you're already doing it complete lah, correct? Something like that. Okay, good. Now, Eben, venture a guess for the integration lah. Integrate this by guessing.
Oh.
Don't be afraid. It's a guess. Nobody will laugh.
Sine.
Mm-hmm. Eben, make a guess. Don't think too much.
3.
3x, sure. Anything else? Okay, if you ended your guess, okay, if you ended your guess, it just means it's time to check. Very simple. People, I'm teaching you this, okay? For integration, you better guess and check and then modify one. It's just an easier way. Don't think too hard. It's very difficult to imagine something that doesn't make sense. The whole problem is with the topic. The topic doesn't make a lot of sense. They cannot explain why this is correct at your level. I am so sorry. Or more like the explanation doesn't help, right? It's too complicated. Right? They just want you to use it. So when I say guess, just guess and check. So let's check by integration. Eben, might as well finish it. Differentiate this, please.
Cosine.
Mm-hmm. Remember, there's an inside here. So
Yeah.
cosine. Mm-hmm.
3.
3x, right?
Okay.
Okay, and then the extra
3 at the
3 and 5. Okay, and by your check, this is not the same, correct? They are not the same. Hey, no surprises, it's a guess. Can you modify?
Yeah.
And modification would be
Half. Half. I don't know.
push modification to take care of this guy. Come on.
Times half.
How can times half take care of 3?
I don't know as well.
Hmm.
Listen.
Let's invite another person to make another guess. Kirana, modify,
Divide by 3.
divide by 3, or if I may rephrase it, times 1/3. Eben and everybody else. What do you think? Now I must put this as 1/3 because that's the modification suggested by Kirana. Second guess lah. Okay, so I put a 1/3 here, right? And then I go and check. Oh, I put a 1/3 here. And does that take care of the problem? Does that take care of the problem? Kira? Yes. Everybody else, if you cannot see that it takes care of the problem, this modification, please tell me. This is still a simple thing. Right, scary stuff, man. Okay, now let's move on. I'm exposing you to a lot of things behind it, the simple rules. Okay, the rule that doesn't make sense, I'm exposing you to all this, right? Okay, bear with me, okay? Bear with me. Okay, this is if you need to know what this means, this is what it means, right? What it means. Okay, basic or we need rule. Anu,
Like to change the first one, the second one.
no, that's up to you. I'm just saying for people who forget Figo, cosine cube x is the same as that guy. Either one is fine. It's not changing. They are the same. They are the same. Okay, just to help you people who forget about Trigo. The question is to differentiate still. Anu, is this basic or do we need some rules?
I think we need rules.
And which one? Times, divide, inside. Does this look like a times? Maybe not. Does this look like a divide? Maybe not. Does this look like a layer? Inside and outside layer. Yes. Now, who is the inside? That's what I teach you. Who is the inside?
Cosine x.
Yes, which is a bit different, right? Let me just compare it with what happened just now. What happened just now is, for example, cosine 3x. The 3x is the inside. And now the cosine is inside. Yes, of course, they are different function. Identifying the inside is important. To differentiate, pretend it is normal. Anu, pretend. What is your comparison? Let me show you a comparison. Your comparison should have been x cubed. Differentiated into, Anu?
3x squared.
Square. Right. This is your basic comparison. And your basic comparison is what you need for a chain rule situation. Because you need to pretend. Now, let's pretend this is x cubed. What is the differentiation of cosine x cubed?
2 cosine
3, you mean.
3 cosine x cubed.
Cosine x square, you mean.
Oh yeah, sorry.
Okay, again, doesn't make a lot of sense, but I am drawing comparison, isn't it, people? I am drawing comparison. But Anu, as everybody else know, we have to do something extra for the inside. The extra is the differentiation of cosine x. What is it?
Negative sine x.
Negative sine x, put it in front times. And for some strange reason, people, this is the differentiation of cosine x cubed. I'm still following the same rule, just different situation. Okay. Any questions? Any question? Now, for your comparison, I'll do this one more time. This one is minus sine 3x times 3. Okay. So they are different. Of course, the function itself is different. Try again. I sense that you guys are following well, so I'm giving you an even harder one. Even harder one. Okay. Joel, basic or not?
No.
Okay. You have a real problem here, yeah? What rule?
A combination, like
And thank you very much. A combo of what rule and what rule?
the quotient rule and the chain rule.
Thank you. For the first time people, you will see combo rule. No matter how difficult this is, the teaching is this, hey, if I combine rules, I can solve everything in differentiation. I just have to know how to do it. So, especially in a combo situation, if you already realize the need, Joel, everybody else, you're off to a good start. The second thing you must do after realizing, hey, I might need a combo, I might need this rule and that rule, is to set it up for you, to set it up to ourselves. Joel, can you set it up for us, please? Somehow make it nice.
Is it sine 3x over cosine 3x?
And if I agree with you, I am saying that, hey, I would rather deal with this than that. This is better. It is easier for me. I know how to deal with it. That's where we know the setup is correct. I agree with Joel's setup. Now, I will still do it with you people. That's what we're going to do. I'll still do it with you. This is a setup for a quotient rule, which also need a chain rule. But the quotient rule seems major, so I must prepare for quotient rule, which is, this is how you prepare, right? Because u prime v prime, the quotient rule, u prime v minus u v prime over v squared, memorize that after a while. Okay, Joel, help us. What is the u prime?
U prime is cosine 3x times 3.
In front. And look at Joel doing chain rule while he is doing quotient rule preparation. It's not that complicated if you do it step by step. Okay, Joel, I'm gonna invite somebody else, yeah? Okay. Matthew, V prime, please.
Negative sine 3x.
The normal thing, and then do a modification in front, the extra thing, times
Times 3.
3. Okay, if I have to rewrite, this is minus 3 sine 3x, okay? Okay, are we done with the quotient rule preparation, Matthew? Can we assemble now, basically? Can we assemble now?
Yeah.
Okay, Matthew, you always kena quotient rule, right? Assemble, please.
3 cosine 3x
Which is your u prime times
times cosine 3x
times v is cosine 3x, correct?
minus sine 3x
Minus sine 3x.
times negative sine 3x.
As complicated as it seems, this is just assembling things over
Cosine squared 3x.
Now, Matthew and everybody else, of course, we have to continue simplifying, but simplification is no longer our concern for now. If you can understand what I'm doing and write down and feel rather okay, I'm already very happy. Very, very happy. Okay. Now, if you have no more question on this one, I'll give you a very similar question. You try yourself. This is the hardest question for now. I hope you have written your notes because I will have to change page. No questions, people? Good. Now, I keep forgetting. Okay, now to practice yourself, ln 3x over sine 3x. You know what? I'm going to change it a bit. I'm going to change this to 5x. People, please differentiate this. I will give you around 3 minutes and then I will start myself. Okay, look at your notes, look at your examples, please. Okay, because things does not make sense right now. Feel free to ask questions. Don't get stuck for 3 minutes. Take your time. Observe what happened in the previous question. Apply it. Absorb all this skill. And make your life easier. Make your life easier. Okay, people, time is up. I'm just going to do it slowly. If you feel that you can finish it yourself, of course, please do lah, right? Of course, please do. Okay, Nicholas, which rule?
Uh, inside,
There is an inside, so we need chain rule. I understand. Is there any other rule that we need?
what is it? The
The
one where
division
like
rule, is it? The division rule, we'll call
the
it
one
the
where I
division
add a
rule.
power -1.
I'm sorry, you're saying? Sorry.
The one where you add the power -1.
Are you referring to the division rule, maybe?
Yeah.
Okay, the quotient rule. Okay, right. So looks like the major thing is the division rule. Let's assign this as U on top. Let's assign this as V. So preparation, please, Nicholas, quickly, yeah. U prime, what is it? No, U prime is the harder one.
3x -1.
3x minus 1 over here. That's Normally treating ln 3x, very good. And then the adjustment in front,
3.
3, very good. For those who you might be surprised that this is actually 1 over x, but yeah, that's the result. We are combining basic stuff with chain rule inside a quotient rule. Nicholas, if this is what you did, good job. You're not bad at following, isn't it? Everybody else, if you're confused with u prime, tell me. Okay. If you feel just uncomfortable, just write down and follow me, right? Now, v prime, Nicholas.
5 cos 5x.
You're doing it faster, your chain rule. That's great. I love it. Are you ready to assemble? Do you remember the quotient rule?
Yeah.
Which is, tell me, it's nice to
U
practice.
prime v minus u v prime over v squared.
Hey, very good. Are we ready to assemble?
Yeah.
Quickly then.
Wait.
Come on, we did our preparation, man. U prime.
1 over x
Nice.
times sine 5x
Nice. Minus.
minus ln 3x
Nice.
times 5 cos 5x.
Okay, over.
Sine squared 5x.
Yeah. Now, whether we can simplify this or not, we should try, but we are going to stop here for now. As long as you can follow this, I'm already very happy. Any question? I mean, you can simplify this. It's just that I'm not doing it today, you know? Never mind for now. Never mind. Really never. Clear? Clear, yeah, everybody? Okay. I'm very happy people can follow. I am going to go slightly harder, slightly harder, slightly harder. Now, I'm going to do double layer or double chain rule. Okay, this is the most they will go, but they will do this. They will do this, okay? They will do this. So I have to do it lah. We have a normal sine x, just for comparison, okay? Cosine x. And then we have sine 2x, which is 1 layer. There's your 1 layer, right? So we have cosine 2x times 2. Just repeating stuff, okay? Just repeating stuff. This is 1 inside, 1 outside. I'm giving you double layer. Sine square 2x. And the square will be very confusing. I'm going to put it as 3. At this point, power 1 doesn't matter, 1. Okay, people, first thing first, please recognize this new guy has more than 2 layers. Okay, more layers. Never mind, I'll just call it more layers. I'll make it very clear, people. Sine 2x, and then everything cube. Do you see that? This is inside number 1. This is inside number 1. This is inside number 2. Inside 1, inside 2, and then outside. Okay, more than 1 layer. Observe that first. We're going to do our chain rule now. Okay, so right now, we need a few things to help us. We need this one to remind us. We do need this one to kind of remind us. And we also need an x cube because the cube is the outermost layer. We need that to remind us also. We're just using basic stuff here in the end. The differentiation is 3x squared. Okay, now watch how I handle more than 1 layer. I will always handle it from some students, some prefer it from the inside. Okay, I'm going to do something slightly different. I'm going to handle it from the outside. So I'm going to apply this. How do I apply it? Oh, very simple. 3, 2, right? Put the sign 2x there. There you go. Okay. This is my starting point. I start here. This is my first step. If somebody is confused, please tell me. Okay, now my second step is, I mean, to keep it simple, I just have to apply this in, right? Because the inside is just sine 2x. For those who are comfortable, I only need to put in 2 cosine 2x. I automatically handle the 2 inside layer and then I am done. I'm trying to do this as much as easily as possible. I'm doing this in just 2 steps because I am experienced with sine 2x. Okay, does this make any sense? If this doesn't make sense, please tell me. Okay, at this point, if you roughly can follow, I just need some thumbs up. Okay, let me just see whether you guys are okay or not.
Teacher, I
Yes,
can barely
Nicholas.
understand the blue and the green.
Okay, you mean the green don't understand, the blue also don't understand?
No, like the handwriting.
Oh, the handwriting. Sorry, the green is fine, right?
Okay, it's okay.
Okay, the blue
But
one, I'm just doing 2 cosine 2x. The blue one,
okay.
It's nothing unfamiliar at this point. Okay.
Chair.
Yes, Anu.
So first we like differentiate the red part, right?
I'll call it outermost layer. I usually prefer to do that. I think it's a better way. Teacher tends to do the blue one first. I tend to do the green one first. This way you'll have 2 point of view. One from school, one from me. Later on, you can choose whatever you want. When you're good, you can do whatever you want.
Oh yeah.
But yes, right now, Anu, I'm doing the outer layer first.
So after that we get the green part, right?
We get the green part, which is the outer layer. And then we focus on the inner part, and then we just put it in front.
Why is it in front though? Like if you're differentiating the sine 2x, shouldn't it be inside the bracket?
The sine 2x is inside the bracket, and we don't touch it, right? We don't touch it. But remember chain rule. For whatever chain rule is, which doesn't make sense, chain rule asks you to handle the inside, differentiate the inside, put it in the front. Correct or not? That's what chain rule asks of you. Correct? In this case of sine 5x. Oh, let's put cosine 5x, but differentiate the 5x as 5, put it in front. That's how chain rule works, I guess. Can I say that? We have been doing that since the start. We have been. Would that be okay?
Yeah.
I'm just doing the same thing, but it just looks more complicated. Still same rule. Still same rule.
Okay.
Questions? Okay. Again, I promise you, triple layer. This is triple layer. Outside, inside, inside. This is the most they will go. Okay. They rarely do it, but they will go up to this point. That's it. Okay. So if we can get this kind of, we are ready for prelim question. That's the goal anyway, right? Okay. So I'll give you a few more triple layers. You know what? I'm not gonna do that. I'm gonna do something slightly easier first. Sine 2x. There you go. If you're familiar with sine 2x, you won't even consider this a triple layer. You just consider it double layer. Okay. For explanation purpose, I'll consider it triple layer. Outside, inside, inside. The outside is obviously e power. So to help us, we need ex to remind us that ex, the differentiation is e power x lah. So let's differentiate this. Differentiate this. A is the exact same thing. Y, look at that. Exact same thing. According to chain rule, you have to, however, put something extra. Here's the extra. And then you have to differentiate the inside. For those who are familiar, you will just write this as cosine 2x and then times 2 lah. And then you are done. I mean, for all the difficulties giving us, it now looks kind of easy, I hope lah. Any question, people? Okay, I guess now I can give you a harder one. E sine x. Oh my goodness, it's gonna be fair. Where? Yeah. This is really a triple layer. Really a triple layer. Okay. Okay, I'll give you 3 minutes to try this one. It's the hardest one. Okay, people, I will start to do it. The outermost layer is e power x, so to speak. So if I differentiate this, I acknowledge that, hey, it's the same thing. I'm supposed to write e sine square x also. The extra is where you differentiate the inside. The first step should have felt easy lah, because the basics are easy. I'm going to do the extra right now. The extra might appear hard. I don't know. We'll see. Can I confirm everybody's okay with the first step? If no complaints, I'll take it as a yes, yeah? Okay, now I'm going to do extra. If you're good, just do it immediately. If not, why don't you separate? Put it on one side and just say, I just want to focus my mind on differentiating sine square x. Okay, which is better known as like that. That's easier for some people to see. I do recommend this lah. Ariel, do you want to give it a try differentiating this guy? Ariel,
What? Sorry, what?
do you want to give it a try differentiating this guy?
Not really.
All right. I'll give you a guide first then. The guide should be x squared differentiated to that. Now, Ariel, I do want to try. I do want you to try, yeah? What is the differentiation of x squared?
Or 2x.
Very good. Now, use this as a guide, Ariel. If I want to differentiate sine x squared, it will first appear as something like this. So tell us, what is it, Ariel? Yeah. Observe the difference. Oh, sorry. Just observe the difference. Look, there's a square here. There's a square here. So
Yeah.
this becomes
It
x.
just becomes, doesn't it just become like sine 2x?
Must put the 2, yeah? 2 in front.
Oh.
Sine x power 1, correct?
Yeah.
Now that's the normal thing, right? Because our guide says so. And then we acknowledge we need a chain rule, right? This is the inside, correct? So you still need to put something extra in front and differentiate the inside. Well, differentiating sine x is not very hard. What is it?
Cosine x.
Cosine x. And according to chain rule, whatever it means, I know it doesn't make sense, you are finished differentiating sine x bracket square. Now that means Ariel and everybody else, all we have to do is plug this here, right? That's all we have to do. That's taking care of the extra. So I'm putting this as cosine x to sine x in front, and then we can call it a day. This is the hardest so far. Very happy that you can follow me up to this point. Everybody, is there a question? If I may know, you can thumbs up, please. Who got this right by himself? Do a thumbs up. I'm curious. Good, Edmund. Good, Matthew. Okay. Whether that means you're already good or that means you're lucky, I don't know. But that means you're getting something out of today's lesson, no matter how nonsensical it may mean lah, sampai ya, no matter. Good for you. Good for you. I will now switch gear. It must be very tiring. I will now talk about, although something new, I'm going to talk about something rather. Oh, no. Before I'm sorry, why am I doing that? I have to give you some satisfaction, right?
Teacher, I'm not done writing.
I'm so sorry, Nicholas. Let me show you one more time. Okay. Please tell me when you're done. Now, as we wait for Nicholas, I would like to give you some satisfaction. I want to show you prelim questions. Obviously, prelim questions are very hard, right? Supposedly, right? Okay, we are supposed to have completed all our syllabus. I will show you that in prelim questions, certain differentiation, hopefully, will look easy to you compared to what we have been doing just now. Just to convince you that you're doing something useful for exam. Okay, because now certain parts of exam does seem not so bad, I guess. Nicholas, are you done?
No, almost.
Okay. Let's wait.
Done.
Okay, thank you very much. Now, shouldn't be showing you all this. I'll just erase all that. Apologies. Yeah. Okay, great. Okay, my purpose is to show you that this format prelim question is now something you can understand. Okay, I have to make it bigger, obviously. They look very intimidating. Don't worry. Let me take care for you. First, I will take out the intimidating part. I'll take it out. Okay. Just know that the question is find H and K. Okay. So I'm going to eliminate words. Some people get confused with words there. I want you to focus on this thing. In fact, I just want you to focus on this, right? H times E power X. Okay, let's take a little bit of a peek. For some reason, this question seems to have a dy dx. Now, dy dx is just differentiation, correct? Differentiation. So let's pretend that the question is just asking you to differentiate. Let's just pretend that that is what we have been practicing. Okay, I'm not trying to scare you. I'm actually wanting to show you this is so easy, right? Now, Joel, are you concerned with the letter H?
Yes.
Why
bit.
would you? It's just a number.
Oh,
Remember, H is a constant. Are you ever scared if you see 3 e power x? Are you scared with 3?
no,
Okay, let me change 3 to 1 million. Will you be concerned with 1 million?
not really.
Okay, Joel, let's differentiate 1 million e power x. What's the result?
This e power x and
Just
then
1 million, right?
million e power x. Yeah.
That's it lah. Because number in front doesn't matter. Just to emphasize the point, Joel, I give you a very weird fraction, okay? 3 over 71, whatever that is. E power x. What's the differentiation?
Negative 3 power over 71 e power x.
Yeah, the fraction just follow lah. That
Yeah.
is what you have been training anyway, right? The number doesn't matter one. Joel, to start off this question, what's the differentiation of h e power x?
H e power x.
E power x times h.
Yeah.
Can everybody accept? Okay, nothing scary. You know roughly what's going on just because of the force of habit. Believe it or not, you have been doing this only for today. Your brain is starting to accept this already. I mean, good job lah, really. Good job. Okay. Now, because the h e power x is so easy, I'm just going to erase that for now. Just focusing on the second guy. Okay? The second guy looks a little bit more intimidating. Fair enough. Okay, let's write down. Okay, this second guy. Oh, what is this guy doing, man? Okay. Okay, now let's ask Eben. Eben, you got the previous question correct, the very difficult one. Okay. K over e power 2x. Is this worrying you?
Worrying me.
Yeah. Or can you do it? If you do it, just do it for us.
Do it like differentiating.
Oh, yeah. Because the question seems to ask us to differentiate.
Okay.
Can you differentiate this?
No.
All right. Remember you're in this a little bit. Yes, you're in this a little bit. For those who forgot you're in this,
Oh,
this
I
is
see. I see.
okay. So
E. Oh, like yeah.
yeah, good. Now, for some reason, Eben, this makes it more doable. Correct or not? For some reason. For differentiation, I mean. Okay.
Yeah.
And this is what I recommend for most people. You have to activate your indice a little bit. It actually helps, at least most people. Eben, can you differentiate? Is this basic? Do we need rule? Blah, blah, blah. Same thing.
Um.
Product rule, quotient rule, chain rule. Times rule, divide rule, inside rule, which one?
Wait.
Okay. Now refocus Eben
Oh.
and everybody else. Now I think the minus 2x we can consider this as an inside issue lah. So I think we need some sort of chain rule. Most of you will be attracted to the k, but look, k doesn't matter. That's the most basic thing about differentiation. If it is just a number in front, if this is just 2, you wouldn't care about it too much. Don't let the k worry you, is what I'm trying to say. Don't let the k worry you. What do you do with the k? I just put it there lah. The k does not matter in differentiation integration. Just put it there. Now, let's deal with this guy. What is the differentiation? Like that, right? Because why? Because we remember e power x differentiation e power x. And then we remember there must be something extra because of chain rule. So the differentiation of minus 2x is what, Eben?
No.
The differentiation of minus 2x is?
-1.
No, minus 2.
Serious? Oh. Oh, okay.
Minus 2x, right? Power 1, right? Minus 2x. First thing, power 0, right? Or 0 times 1. Okay, so this becomes minus 2. Anyway, it's the guy in front. Okay, it's the guy in front. So the differentiation of this weird guy is still within our capability. It's not that hard. Okay. If you can follow the H and the K and everything else, people, let me see some thumbs up. Okay, good, good. Anu and Joel, would that be okay? Good, Nicholas. Good. Anu, okay, Anu?
I just need more time. It's okay, you can carry on.
Of course, of course, of course. Definitely. First time, man. First time. Okay, practice will be coming either next year or from me, right? Don't worry. Now,
It's so
I
confusing.
want to show you something which you do not need to worry about. What the heck is this new thing? Ah, yeah, whatever, formal symbol. This thing does not mean square. This means I differentiate again. That's all, okay? That's all. It only means I need to differentiate again. Differentiate who? I mean, I differentiate once. I just differentiate one more time. Nothing complicated. Easy to do. Right? Okay, twice. Kirana, what is the differentiation of h e power x?
H e power x.
And then we're done. That's it. Done. Finish. Sorry. Done. Finish. Okay. What is the next differentiation of this guy? Does the k matter?
No.
Leave it there. Does the minus 2 in front matter? It's a number. Leave it there. Do you understand? Leave it there. The number, just leave it there. Who cares about the number? You're thinking about the wrong thing if you worry. Well, just leave it there, man. The only thing you have to worry is about differentiating e power minus 2x, which you have already done the first time. So please do it for us again. What's the differentiation of e power 2x? E power minus 2x. First, you use this as a guide, so it will become
E to the power of x. Or e to the power of minus 2x.
Because this becomes that, right? And then chain rule say you have to put something extra because there's an inside thingy lah. Yes, the inside thingy. So you just differentiate that inside and put it in front. What is it?
-2.
All right. Don't be confused that they are -2, okay? Please don't be confused, right? If you want, this simply becomes 4k e power minus 2x, okay? This is comparatively easier than what you did just now. You know what? And if you can do this, you're already 2 marks out of 4. 2 marks, is it a lot? Is it a little? Frankly speaking, when you're used to this 2 mark is very fast to do. Okay. Look, you're doing this way before Sec 4 starts. So good for you. This is already 2 marks, man. Already 2 marks. Now, can everybody follow? Will this be okay? Okay, good. If there's no question, I will now open the full question. Okay, I will now open the full question. Just to show you, there is nothing difficult with this prelim question. 4 marks even. Okay. Okay, I have this. I think no problem there, right? Frankly speaking, I now have this. Remember what this is? This is just I differentiate twice. I have it what? This guy is this plus that lah, correct? That's all there is to it. Okay, I will now put this as, oh, this guy is this plus 4k e power minus 2. That's it lah. Okay, that's all there is to it. I also have my first differentiation. Of course, I have it. What is my first differentiation? This and that lah. What is that? Oh, that's just h e power x minus 2k e power minus 2x. No matter how confusing this is, I'm just assembling things. And then I have a minus 2 there, so I just times everything by minus 2. Right? This is what the question wants. That it's not that difficult if you understand what he wants. Okay? Now I need to assemble everything. I am no longer doing differentiation. My last 2 marks, I'm just assembling things. So look, hex plus 4k e power minus 2x times this one minus 2h e power x, and then this one also, plus 4k e power minus 2x. Please don't be alarmed. This is just a lot of indices, but I'm just assembling stuff. Okay. I will now take the opportunity to combine this and make it into minus h e power x. I will now take the opportunity to combine the other guy, combine this one and this one, and then I have plus 8k e power minus 2x. Okay, and then equals to e power x plus 2 e power minus 2x. As confusing as all this is, isn't it obvious? This is this guy. Okay, I'm just comparing this, that minus h equals to 1, h equals to minus 1. Now I compare 8k with 2 because of this thing. 8k equals to 2, k equals to 1 over 4. Okay, now whatever it is I'm doing, I want to emphasize a few things. The differentiation is not that hard. You can roughly follow what I was doing. You can even understand and do it yourself. That's 2 marks. It's not 4 marks, I agree. That's 2 marks. The rest here, no matter how complicated it seems, is not differentiation, it's just algebra. If you hate algebra, it's a different set of problem. We should take care of it lah. Don't worry about that. If you like algebra, that will give you a rather easy 2 marks. This is very common for an integration or differentiation equation. They combine the differentiation with other things. I am just emphasizing the fact that you can understand the differentiation. Okay, that's all. That's all I'm saying. That's all I'm saying. I will show you one more thing. I am so sorry. I did something wrong. Okay, there you go. Look at that, for 3 marks. For 3 marks. First thing first, you can keep doing the wrong thing. you can understand what the question is asking you to do. Hey, differentiate once, differentiate twice. Why are they so obsessed with double differentiation? You'll know later. There's some use to it. So you differentiate once, you differentiate twice. Okay. For the last one, Matthew. Differentiate once for us. Let's differentiate 2. What is the differentiation of 2?
2.
No. Surprisingly, the differentiation of 2 is 0.
Oh,
Actually, we almost never practice this. For now, any number differentiated is 0. Just follow for now. Okay. Now, Matthew, what is the differentiation of minus x? Like to remind you, the differentiation. Differentiation of 3x, the differentiation, the result is
3.
3. What is the differentiation of minus 1x? The result is
-1.
minus 1. So what is the differentiation of minus x?
-1.
Minus 1. As easy as it seems, everybody has to get used to things. Because let's admit it, differentiation is a matter of habit, not a matter of something that makes sense. Getting used to it has a lot of benefit. Now, Matthew, the last one. What is the differentiation of this guy? What kind of rule should you use?
Quotient rule.
Quotient rule, which do you remember? Oh, it's you again. You always kena quotient rule, isn't it? Okay, what is it?
U prime v minus u v prime over v square.
And what's your preparation? The top one is u, the bottom one is v. U prime, what is it? It's so easy. U prime is
2.
2, correct? Definitely. V prime?
1.
1. Because why? Because the differentiation of 3 is 0, right? The
Uh-huh.
differentiation of 2x is 2. Hey, I know that. The differentiation of minus 3, who cares? It's 0. The differentiation of x, hey, it's 1. It turns out it's not that bad. Huh? Okay, so assemble these.
2
2,
times
right?
x minus 3
X minus 3, great.
minus 2x plus 3 over
Times 1. Okay, just to make sure. Okay. Over.
x minus 3 squared.
Right. Let's see. Square. Okay, I'll simplify. Okay. 2x minus 6. Algebra, remember, in a differentiation question, in the end, you have to do some algebra. So, hey, the result is not that intimidating, you know. The result is minus 9 x minus 3 power minus 2. I have some preference in doing it this way. In this, you need to activate your algebra. But let me give you the impression that it's not that hard. It's not like a very complicated thing. Now, all these are your first differentiation. Should you be concerned with your second differentiation? Let's ask somebody else. Anu, what is the second differentiation? Okay, so let's differentiate 0. What is it?
0.
0 lah. What is differentiation minus 1? What is it?
0.
0. Simple, right? What is the differentiation of this guy? What kind of rule should you use? I don't know. What is it? Do you need to use a rule?
I think
Times, divide, inside. Which rule?
inside.
Inside. And the inside will be x minus 3, correct? That's the inside. Okay. For your comparison, therefore, you should be thinking about minus 9x power minus 2. You should think about this differentiation. Make sense? So Anu, please differentiate this minus 9x minus 2. Remember the first step, minus 9x, right? Power.
Minus 1.
Minus
Sorry, minus 3.
Very good. I know it doesn't make sense. And then the third step,
Times minus 2.
Nice one. Okay, so this will become positive 18x minus 3, correct?
Yeah.
Doing it on the side helps a lot when we are starting off. Doesn't take a lot of time. So this is your first step. What is it? So what should you write here?
18x minus 3 to the power of negative 3.
Okay, learning from this, you apply it here, but there's something extra, correct? Extra, you must differentiate the inside, and what is it? The differentiation of x
One.
minus 2 is 1. And oh, wait, I mean, not that scary. Not that scary. So this is your double differentiation. This is the way they write down formally. And this is your first differentiation. This is your first differentiation. And for that, it is 3 marks. You can follow this, you can do this. And definitely with practices. Your teacher will give you a lot of practices. That's why I don't. 3 marks is in the back. Okay. Right. Yeah, I don't think we should go further. I'll now erase this. Please do it one more time. Don't look at your working. Just give yourself the favor of, hey, prove it. You can do this. When you're done, tell me, have a good day, have a good night. Okay? Don't leave until you can do it or at least ask questions. Right? Okay, close your previous working, please. And do this one
Teacher,
more. Yes, Nicholas?
I don't know how to do it at all. I'm
I
completely
will
lost
guide,
the entire time.
yeah, I will guide you, but everybody else just don't hear us, okay? Nicholas, are you clear that the question simply is asking you differentiate and then differentiate again? Clear?
I don't know.
Then I'm telling you, I'm not asking you to understand it. dy dx is just the formal way of asking you, hey, differentiate, man, something like that. Differentiate once, differentiate twice. Can you accept that?
Okay.
Okay, done. Now we are differentiating this guy lah. Okay, can you differentiate 2?
How do you differentiate that again?
A very good question. It's a very good question. Actually, we never cover it too much. Sorry, yeah? Okay, so one more time. Let's start with 2x first. What is the differentiation of 2x? It looks so simple, right? I know. Okay, so try. Remember, Nicholas, the first thing you write is to write 2x again. First step, correct? This is still very basic, man. The power, second thing,
0,
0, good. And then the third thing, you must times.
1,
Okay, now tell me, what is the differentiation of, what is this guy? Isn't this just 2? Let's be okay.
Yeah.
So some people will shortcut this and it's okay. When you see 2x, hey, the differentiation is just 2 lah. When you see 3 over 5x, hey, the differentiation is just 3 over 5. Some people kind of just memorize it that way in the end. I'm okay. I'm just showing you that following the rule still works out. Anything you want. Now, we haven't talked about differentiation of 2. Now, the differentiation of 2. Let's follow the rule. Now, let's make it into 2 power x0 lah, right? Let's differentiate 2 power x0. First thing you write is 2x, correct? Sorry. Correct or not? That's the first thing that you do. The second thing that you do is the power is
-1,
-1. The third thing that you do is times something. What is it?
times 0.
Yeah, which is 0. Ta-da! Some people memorize this as if it is just a number, whatever the differentiation is, it is always 0. And that will be correct. And it means something. So now, let's try the differentiation of 3x, so 2 to the power 5x, power 0. What is it? First, you write 3 over 5x because it's always the same. Then, second thing,
-1 and then 0.
-1 and 0. See, the differentiation of any number is simply 0. If I change it to 1 million, it's still 0. Can? I am following the rule just to show you that the rule works most of the time. What is the differentiation of number 2?
0.
The stack differentiation of 0 is, again, of course, just
0.
great. I hope you're confident.
The
Now,
thing is,
yes.
how does it change when there's no x?
I'm sorry, what? Sorry.
You put the power on the x, but then the 2 got no x.
Sorry, you're talking about this one, is it?
Yeah, you put most of the time it's an x, but then the 2 has no x. So what?
Hey, Nicholas, let's be clear. Are you talking about this one or are you talking about this one? Or which one are you talking about?
I'm talking about all of it. They all have an x.
Hey, Nicholas, I thought we just agreed that the differentiation of 2 is 0 and you can follow. Yes or no?
No, I'm saying they all have an x, and but the 2 in the y equal to minus x minus 2x plus 3 over x minus 3.
What you're talking
That 2
about,
has
Nicholas?
no x. So
Is
how
your
does it become
English,
0?
is your English that bad?
I'm not talking about the x, the 2. I'm talking about the equation of the curve.
Look, is 2x power 0? Yes or no? Yes or no?
I'm not talking about the 2.
Nicholas, let's be very clear. You're talking about this 2, right? Which is
No.
this 2. Why is this 2 not this 2? They're the same thing, is it? Isn't it just the same?
Oh, wait.
What are you
Oh,
talking about? They're just the same, right?
okay.
Clear, yeah? Clear. Clear that in the mind. That's something you do have to clear out. Good. Can we agree then differentiation of 2 is 0 lah? That's it. Will this be okay?
Differentiation of 2 will be 0. Yeah.
Okay. Now we move on to something slightly harder. What is the differentiation of minus x?
Uh, 0.
No, minus 1. Because the differentiation of 2x is 2. The differentiation of 3 over 5x is, well, 3 over 5. So the differentiation of minus x, which let me make it clear, it's just minus 1x. The differentiation is, of course, minus 1. Would that be okay?
Okay.
Okay. Now, what is the differentiation of minus 1?
Uh, 0.
Yep, and you would be correct. I think that takes care of most of the problem, I think. The last part is just quotient rule. Will this be okay? Now, guys, it is late. If our brain is not working, I won't tell you too much lah. Did anybody get it right, or are you stuck? Okay, at least tell me what's going on before we end. Anu, did you manage to get it right?
Yeah, I finished.
All right. Then I will see you tomorrow and good job. All right. Ariel?
Yeah.
All right. I'll see you tomorrow. All right. Eben?
I no, I made some mistake. I made a careless mistake.
No worries. That's why we practice. I'll see you tomorrow. Joel?
See you.
Yup, done.
All right. Good.
Wait,
It's a
can I
heaviest today.
double
What's it?
confirm the answer?
I erase it. I'll just do it for you again later. Would that be
Alright.
okay? All right. Okay.
Okay.
Good job. I'll see you tomorrow. Hey, Matthew?
I did the question, but like I don't really remember the answer, so I don't know whether I'm right.
I'll send it to you later. Okay?
Yeah.
Okay. Good
Okay,
job.
thank you.
Okay, Nicholas, for now, let's end today, okay?
But I don't understand dy dx. They're completely different. There's no d in the equation curve.
We'll talk about the formalities next time, okay? I promise, okay? I think you're just stuck with the formalities lah.
How come they know like
Mhm.
what's d?
Because I told everybody every time that that's just a formal way of asking you to differentiate. Never mind the d, never mind the x. You're too focused on something unnecessary. dy dx for now is just their formula.
Then how about the 0 and the -1 and everything? I don't know.
They just follow better. You just get stuck in the start. That's normal and usual. I gotta end this, okay? We'll repeat again tomorrow. I'm sorry, you don't. Okay, I'll send you the recording and then you can review again because I did tell this a lot of times. Okay, you're just stuck on formalities. That's the good news. Okay, all right. We'll stop for
Okay.
now. Okay, right. I'll see you then.